Today we're going to look at continuity, and we're going to start our discussion with continuous at a point and using the checklist that's in the book. So they say or tell us that we are continuous at a point if three things happen. So the first thing is that f of a has to be defined. Okay. The second thing is that the limit has to exist. And the third thing is that these two have to be equal. Okay, so what these facts mean is that the first one means that your function is filled in. Okay, so there is a dot at A. Boom, dot, filled in. Boom. The limit as x approaches A of f of x exists means that as I approach from the left and the right, I'm going to the same spot. Okay, so this is just saying that that happens. This third thing is saying that when I put these two pieces together, this is happening, but this dot is filling in right at that spot. Okay, all right, so when I'm looking at a function, so let's say that I'm given a function like, I don't know, x squared plus 4, and I'm asked if this is continuous at A is 5. Okay, so if I'm asked, is the function x squared plus 4 continuous at A is 5? I'm like, yeah, this function's continuous everywhere, right? Polynomial. Yeah, of course it's continuous at 5. It is filled in at x is 5, okay? As I approach from the left and the right, it's going to that thing. Yep, I'm good. All three things are true. However, if I were to look at a function like at this spot, okay, this spot, I'm like, ooh, when I plug in f of 4, let's see what happens when I plug in f of 4. I get 0 over 0. And we know for a fact that when I get 0 over 0, that's a hole or a removable discontinuity. So this is definitely not continuous at this spot. Okay, now, in the homework it asks, well, where does it fail? Well, if you think about a hole is this. So where it's failing is two things. One is that it's not filled in at all, and it's not filled in at that spot. So this is failing this, right? It's undefined. It doesn't exist at all at that spot. And it's failing this. So this is failing the checklist 1 and 3. Okay. The previous example didn't fail at all. It passed all 3 points, or all 3 of the checklist. Okay. Let's try another one real quick. What if I wrote f of x equals 1 over x minus 2, and I asked us to do A is 3. Okay. Now some of you are going, oh, it's a vertical asymptote. Oh, no, I didn't ask you about where the vertical asymptote is. If I plug in 3, I get 1. So what's happening here is that when I plug into the function, I get an answer. It passes this. And technically, it's also passing these two because this graph is continuous everywhere but at x is 2. That's my problem spot. So as long as I'm being asked about a spot not at the vertical asymptote, then all 3 of these are good. So this would be an example of I pass all 3. So I'm passing all 3. Okay. What would it look like if I didn't pass all 3? Well, basically, this example here where I'm failing 1 and 3, or maybe I just fail 1, that it has to be defined, or I could honestly fail all 3 things. Okay, now, before I finish this video, and you're probably going to be rewatching it a lot, here's what I mean by I'm failing all 3 things. What if I go over here, and instead of asking about A is 3, I ask about A is 2? Okay. What happens when I plug in 2? It's undefined. So I'm failing 1. So I fail at 1. Boom. We could stop right there. It turns out, though, if we keep talking about stuff, though, the limit does not exist as I approach 2. This vertical asymptote that I'm approaching is splitting off to a positive infinity and a negative infinity, so it's actually failing 2 as well, and failing 3. So failing 1 was enough to just fail the whole thing, but technically it's also failing 2 and 3 as well. All right. Do your best in this part of the homework. I know it's a little bit tricky. It's not hard to know that you've got a problem. It's hard to be specific about which problem it is. Okay? So for most of these, they're going to fail the first, that it's not even defined at that spot. For a rare few, they're going to fail 1 and 3. Okay. Keep at it. It's going to be okay.